Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Let's build on what you've learned. Pause and try to remember. In Episode 3, how does Aurora replicate across regions, and can both regions accept writes? Take a second. Aurora, storage layer replication, 45 to 85 milliseconds lag, active-passive architecture. Only the primary region accepts writes. The secondary is read-only until you promote it. This works great for hot-warm. Primary handles all writes, secondary stands ready for failover. But what if you need hot-hot? What if you need US East 1 and US West 2, both accepting writes simultaneously? Users in both regions writing at the same moment? Aurora can't do this. The primary writer lives in one region. You cannot write to the secondary without promoting it first, and promotion takes 90 seconds. That's not hot. Today, you're learning about DynamoDB Global Tables, active-active replication where every region accepts writes. This is fundamentally different from everything we've covered so far. By the end of this lesson, you'll understand how DynamoDB achieves multi-region writes, how to handle conflicts when two regions write to the same item at the same moment, and most importantly, when this is worth the cost and complexity. What you'll master today: how DynamoDB Global Tables achieve active-active replication with sub-second lag. Conflict resolution strategies when two regions write simultaneously to the same data. When to use DynamoDB over Aurora, and critically, when not to. And the hidden costs that can hit $25,000 monthly for high-traffic tables. Let's start with the fundamental difference between what we've learned and what we're about to explore. Aurora. One writer, multiple readers. Active, passive. DynamoDB Global Tables. Multiple writers, multiple readers. Active, active. This changes everything. Picture a global gaming application. Players in US East 1 and EU West 1 simultaneously. A player in New York updates their score. A player in London updates their inventory. Both writes happen at the exact same moment to different items in the same table. With Aurora Global Database, you'd need to route all writes to US East 1. The London player's write has to travel across the Atlantic, hit the US East 1 Aurora primary, then replicate back to EU West 1. That's 150 to 200 milliseconds round trip. For a real-time game, that's noticeable lag. Players feel it, complaints roll in. With DynamoDB Global Tables, the London player writes to EU West 1. The New York player writes to US East 1. Both writes succeed locally in 10 to 20 milliseconds. Then DynamoDB replicates asynchronously in the background. Sub-second replication. Typically 1 to 3 seconds later, both regions have both updates. This is the power of active-active, and it's exactly what hot patterns need. Here's how it actually works under the hood. You create a DynamoDB table in your primary region. Enable Global Tables. Add replica regions US West 2, EU West 1, wherever you need presence. Every region becomes a full replica with read and write capability. Writes go to the local region. Fast. Low latency. DynamoDB replicates to other regions asynchronously. There's no primary, no secondary distinction. All regions are equal. All can accept writes. The replication lag is typically 1 to 3 seconds. Not the 45 to 85 milliseconds you get with Aurora, but acceptable for most workloads. The trade-off is worth it. You get multi-region writes. Why is replication slower than Aurora? Aurora ships minimal redo logs at the storage layer. Tiny, efficient. DynamoDB replicates full items at the application layer. Bigger payloads, more processing. But you get the capability Aurora cannot provide. True active-active writes. Now here's where this gets tricky, and this is where most teams mess up. User updates their profile in US East 1, sets email to new@email.com. Same user, same exact moment, updates their profile in US West 2, sets email to different@email.com. Both writes succeed locally. Both regions think they have the correct value. Now DynamoDB replicates. US East 1 sends new@email.com to US West 2. US West 2 sends different@email.com to US East 1. Which value wins? This is the conflict resolution problem. Get it wrong, and you have data corruption. Silent, subtle, hard to debug data corruption that manifests weeks later in production. DynamoDB's default solution, last writer wins. Timestamp-based conflict resolution. Each write gets a timestamp. When conflicts occur, the write with the latest timestamp wins. In our example, if the US East 1 write happened at 10:000.100 seconds, and the US West 2 write happened at 10:000.150 seconds, US West 2 wins. Different@email.com becomes the final value in both regions. The advantages are clear, automatic, no custom logic required. Deterministic. The same conflict always resolves the same way. No application changes needed. DynamoDB handles it. But the limitations will bite you. Clock skew between regions can cause the wrong winner. A WS synchronizes clocks via NTP, but they can drift. If the US East 1 clock is 2 seconds ahead of the US West 2 clock, US East 1 writes always win, even if they happen second. You get lost updates. One write gets silently discarded. And there's no way to preserve both values. I've seen this cause production issues. User updates their address in one region, updates their phone number in another region. Last writer wins means one update disappears. The user sees their address change, but their phone number didn't update. They try again. Same problem. Support tickets pile up. Nobody understands why. The better approach, design your data model to avoid conflicts in the first place. Strategy 1. Partition by region. User data lives in their home region. Users don't roam between regions mid-session. No conflicts because each user only writes to their home region. Simple, effective. Strategy 2. Merge semantics. Instead of overwriting, merge. For a shopping cart, append items rather than replacing the entire cart. Use DynamoDB's atomic increment for counters. Conflicts become additions, not replacements. Strategy 3. Read, modify, write with version checks. Read the current version number, modify the data, write with the expected version. If the version changed between your read and write, retry. This detects conflicts and lets your application decide what to do. More complex, but gives you full control. Here's a real production pattern that actually works. E-commerce with global customers. The user's home region is where they registered. Shopping cart updates go to the home region. Sticky sessions from episode 4, keep them there. Inventory and catalog replicate globally, but from the user's perspective, they're read-only. Back-end systems update them. Orders write to the home region, then replicate globally for fulfillment tracking. This design minimizes cross-region conflicts while still providing global access to data. The key is understanding your write patterns and designing around them. Now let's talk about when you should use DynamoDB versus Aurora, because this decision has massive cost implications. Use DynamoDB Global Tables when you need active writes across regions. That's the hot pattern from episode 2. Your access patterns are key value or single item lookups. That's DynamoDB's strength. You can tolerate eventual consistency. 1 to 3 second lag is acceptable for your use case. You need unlimited scale. DynamoDB auto-scales to millions of requests per second. And when your data model fits NoSQL denormalized, no complex joins. Real use cases. Session stores where user sessions are read and written globally. Gaming leaderboards where players update scores from anywhere. IoT device state where devices send data from multiple regions. Shopping carts where users shop from any region. User preferences and settings. Low conflict profile data. Use Aurora Global Database when you need a relational data model. Complex queries, joins, multi-table transactions. You're okay with active-passive. Hot-warm is sufficient for your RTO requirements. You need strong consistency, not eventual. Nashes. Your access patterns require SQL flexibility. When you want lower replication lag, 45 to 85 milliseconds versus 1 to 3 seconds matters for your workload. Real use cases. Order management where transactional integrity is required. Financial records where strong consistency is critical. Inventory systems where ACID transactions are needed. User authentication with relational user, role, and permission data. Here's where DynamoDB becomes a cost trap. Aurora pricing is predictable. Instance cost plus storage plus data transfer. You can calculate it up front. DynamoDB pricing scales with traffic. Write capacity units and read capacity units multiplied by the number of regions. High traffic means high costs. Let me show you the math that surprises teams. Application writes 1,000 items per second. Reads 5,000 items per second. Each item is 1 kilobyte. 3 regions. US East 1, US West 2, EU West 1. Writes 1,000 write capacity units per second in each region. Because all regions accept writes, each write costs you in that region. Reads 5,000 read capacity units per second in each region. Users read from their local region. Replication 1,000 write capacity units times 2. You're replicating to 2 other regions. That's 2,000 additional write capacity units per region, just for replication. Total per region, 1,000 WCUs for application writes equals $6,000 per month. Naily, 2,000 WCUs for replication writes equals $12,000 per month. 5,000 RCUs for reads equals $3,000 per month. Storage, 100 gigabytes times 25 cents equals $25 per month. Per region cost, $21,025 per month. 3 regions, $63,075 per month. Aurora equivalent for comparable scale, $5,000 to $8,000 per month. The DynamoDB cost is 8 to 10 times higher. You're paying for auto-scaling. Zero administration. Active capability. Unlimited scale. These capabilities have value, but you need to know the cost up front. Let me show you optimization strategies, because these costs add up fast. Strategy 1. On-demand versus provisioned capacity. On-demand pricing means you pay per request. No capacity planning. Good for unpredictable traffic. Provisioned capacity means you reserve capacity up front and get discounts. Good for steady traffic. For global tables, provisioned can save 50% if your traffic is predictable. Strategy 2. Not all regions need to accept writes. Make some regions read-only to save on replication costs. Your application routes writes to primary regions. Reads go to the local region. You still get global read access with lower replication overhead. Strategy 3. Use time to live for ephemeral data. Session data, temporary state, configure TTL to auto-delete after expiration. This reduces storage and replication costs. No manual cleanup required. Strategy 4. Right-size your items. Write capacity units are calculated as bytes divided by 1 kilobyte, rounded up. A 1.5 kilobyte item costs 2 WCUs. A 1.0 kilobyte item costs 1 WCU. Optimize item size to stay under 1 kilobyte boundaries. Split large items if needed. This can cut costs in half. Common mistakes I see repeatedly. Mistake 1. Treating global tables like single-region DynamoDB, teams assume strong consistency across regions. Reality is eventual consistency with 1 to 3 second lag. Fix. Design for eventual consistency. Use version checks. Show users synchronizing across regions, messages, if needed. Mistake 2. Not planning for conflicts. Teams use default last writer wins without understanding implications. Reality is silent data loss, wrong values persisting. Support tickets piling up. Fix. Design your data model to minimize conflicts. Use merge semantics. Partition by region where possible. Mistake 3. Cost blindness. Teams enable global tables without calculating replication costs. Reality is $60,000 per month bills for high-traffic tables. CFO demands explanation. Engineering scrambles to optimize after the fact. Fix. Calculate write capacity units, including the replication multiplier before you build. Use provisioned capacity for steady workloads. Mistake 4. Using DynamoDB when Aurora would work. Teams choose DynamoDB for hot-warm patterns where they only need active-passive. Cost. Paying 8 to 10 times more for capability they don't use. Fix. Use Aurora for hot-warm. Use DynamoDB only when you actually need hot, active writes. Before we wrap up, pause and answer these questions. Question 1. What's the key difference between Aurora Global Database and DynamoDB Global Tables in terms of write capability? Question 2. Your application writes 500 items per second. Each item is 2 kilobytes. You have 2 regions. How many write capacity units are needed per region? Question 3. When would you use DynamoDB over Aurora? Answers. Question 1. Aurora is active-passive. Only the primary region accepts writes. DynamoDB is active-active. All regions accept writes simultaneously. This is the fundamental architectural difference. Question 2. Each 2 kilobyte item needs 2 write capacity units. That's bytes divided by 1 kilobyte, rounded up. 500 items per second times 2 WCUs equals 1,000 WCUs for application writes, plus 500 WCUs for replication to the other region. Total per region, 1,500 WCUs. At standard pricing, that's $9,000 per month per region just for writes. Question 3. Use DynamoDB when you need hot, active writes, can tolerate eventual consistency, have key value access patterns, and need unlimited auto-scaling. Don't use it if you need a relational model, strong consistency, or can get by with hot-warm. Aurora is 8 to 10 times cheaper for hot-warm patterns. Let's recap what we covered. First, active replication. DynamoDB Global Tables allow writes in all regions simultaneously. Aurora only allows writes in the primary region. This enables hot patterns, but comes with complexity. Second, conflict resolution. Default is last writer wins based on timestamp. Clock skew can cause wrong winners. Application level resolution is better. Design your data model to avoid conflicts in the first place. Third, replication lag is 1 to 3 seconds typical. Slower than Aurora's 45 to 85 milliseconds, but acceptable for many use cases. The trade-off for active capability. Fourth, cost multiplier for replication. N-1, write capacity units per region, where N is region count. 3 regions means 2 times replication cost on top of application writes. This adds up fast. Fifth, use cases matter. Hot patterns, key value workloads, eventual consistency acceptable. Use DynamoDB. Hot-warm patterns, relational data, strong consistency. Use Aurora. Don't pay 8 to 10 times more for capability you don't need. Remember episode 2? Hot pattern with sub-second RTO? DynamoDB Global Tables is how you implement that for NoSQL workloads, but it costs 8 to 10 times more than Aurora hot-warm. The CCC triangle from episode 1, your trading cost for capability. Episodes 3 through 6 gave you the data layer options. Aurora Global Database, active-passive, relational, 45 to 85 millisecond lag, 5 to 8,000 per month. DynamoDB Global Tables. Active, NoSQL. 1 to 3 second lag, 25 to 60,000 per month. Choose based on your actual requirements. Not aspirational architecture, not what sounds cool in architecture reviews. Your actual business needs, access patterns, and budget. We'll revisit DynamoDB costs in Episode 9, Cost Management, with detailed optimization strategies. In Episode 10, Data Consistency Models, we'll explore the CAP theorem and why DynamoDB chose availability over consistency. And in Episode 15, Anti-Patterns, we'll see what happens when teams use global tables wrong, the production outages, the data corruption, the lessons learned. Next time, observability at scale, centralized logging and distributed tracing. You've got Aurora replicating data, DynamoDB replicating data, EKS clusters running workloads across regions, network layer connecting everything. All of this is distributed. All of this can fail. How do you troubleshoot when things break? When a request fails, which region was it in? Which service failed? How do you trace a request that touches 3 regions and 5 services? Where do you even start? You'll learn centralized logging with CloudWatch Logs Insights and S3, how to aggregate logs from multiple regions without drowning in noise, distributed tracing with X-Ray for multi-region request paths, how to follow a user request from US East 1 through your API in US West 2, cross-region metrics aggregation and alerting, how to build dashboards that show your entire global architecture at a glance, and the observability patterns that prevented 2 AM pages, the real techniques production teams use, because multi-region without observability is flying blind. When production breaks at 2 AM, you need to know where and why, fast. Before the outage costs you $100,000 in lost revenue. See you in Episode 7.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.